This is our final project presentation for the Kakapos group, and we did the educational video game. So my name is Kennedy Tate.
My name is Bruno.
My name's Chris.
And my name is Pratik.
To begin with, we're going to talk about the design cycle and how each of its parts relate to our project.
First, we have to define the problem. Our problem was to design and create an educational computer game that is creative, fun to play, appropriately challenging, and teaches students a particular STEM topic, such as chemistry, physics, or biology. Next, we did a little bit of background research. We found that the appropriate age range for a game-based learning is 8th through 10th grade. We concluded this because students in this age range first learn about advanced biology, chemistry, and physics. Game-based learning is effective to apply concepts learned in the classroom, become independent learners, and develop skills such as systems thinking, problem solving, and 21st century skills. We found that to create the most effective game, it had to be interactive, immersive, and have regular feedback and appropriately leveled challenges. Next, we brainstormed and had to decide a solution. Our first option was to create a lab-based chemistry game. We figured this might be a little complex, especially since we weren't that knowledgeable in chemistry. Our second option was to create a kinematics-based physics game. This isn't too challenging to create, and it can easily apply to real life, like through sports. Clearly, we chose option 2.
And our next part is developing solutions. So we improved our game design over the course of about a month and a half. And from these two images, we added better graphics, more levels, and extra features. The image on the left was our first prototype of the game, and had very rudimentary graphics and some pretty bad bugs. And the image on the right shows a more recent version of the game. As you can see, we updated the graphics, and we also added a high score table and a stroke counter. For our testing solutions, we played through our game many times to find the bugs and fix them, test play time, and search for improvements that could be made. And for our results, on the right, we have a screenshot of one of the later levels in the game that ended up in our final project. And I'm actually going to do a quick demo of the first level of the game for you. So go over here. This is the title screen with our logo. This is the welcome page. And here's the first level. So to control the game, we input an angle that we want to fire the ball at, and we choose a speed in between 5 and 50, and then the club hits the ball in the specified angle and with the specified velocity. So now we want to hit backwards, so we'll do one greater than 90, and then probably a little bit less power this time. And oh, almost got it in there, but close enough where you can probably just go like that. So that was our first level of the game.
Throughout the design cycle, we ran into some challenges that we had to deal with. Some of these stemmed from the limitations of Scratch, which was the program we were using. And part of this was how Scratch moves objects. And the way it does it is it practically picks it up and places it in a new position, meaning that if it moved too much or in a weird way, it could end up skipping objects that would normally hit, and that would make it bounce off or react differently with. And so we decided to design our levels around these limitations, making it so the bugs were as least likely as possible. And also, Scratch made so only one person could be working on it at a time, since there's no way to see changes made on other computers onto the project. So the way we went around this was either made so one person worked on certain parts at a time, or we met together and did Zoom calls to work on it together. Another problem we ran into was that none of us had really any skills in designing images for the game, so we decided to use royalty-free images that we found online to replace this lack of skill that we had. And finally, the online setting made it also fairly difficult, as we could only meet up for Zoom calls whenever we had to get something done, but this did allow for cooperation, even though we didn't get to meet in person.
So the thing we would do different is not like a big difference, cause a big difference on the game, would not cause that difference. But because we think we have reached a good level overall. We have accomplished great things with this game. We have approached a lot of things concerning physics. So what we could do to make it more attractive and more dynamic would maybe include the other modalities of sports. So maybe basketball and football and things that sports you where you can throw things and would be perfect to this extent. And we could also add multiplayer mode for kids to play with their colleagues. And we could also ask people to try out and give us feedback before the final result. And our advice are kind of simple but very important to the future students. Don't worry about the final result. It's gonna be okay because if you work well, if you try to enjoy your work, which is the most important, certainly you're gonna have a nice result at the end. And also try to work ahead of time on the assignments because the due date is very strict. And also try to make your group chat and call on Zoom, as we mentioned, was very important. And read the textbook chapters because you may find some quizzes on them. And here we have our references if you guys want to look at it, add them further. And thank you. That's it. Thank you very